Example 3. Determine A16 and AN for the arithmetic sequence 23, 20, 17, 14, and so on. All right, so first thing we're going to do here is confirm that this sequence is arithmetic. Yes, we're told that, but it doesn't hurt to check. Okay, so if we start with 23 to get to the next term, to go to 20, we need to subtract 3. And then to go from 20 to 17, we also subtract 3. And then to go from 17 to 14, we subtract 3. And so the dot 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 means this trend continues. Okay, so what this tells us is that the common difference here is -3. If I want to go from one term to the next, I have to subtract 3. Okay, so remember, the other way you could get the common difference is to take a term, doesn't matter which one, as long as you know it's an arithmetic sequence, take a term and subtract the one that came before it. Okay, so you could have picked 14, for example, okay, and then subtracted the term that came before it, which would be 17. That's going to also give you a common difference of -3. Okay, it matters if the common difference is -3 or if it's +3. Okay, you have to look at the common difference as, if I'm going from one term to the next, how do I get there? Okay, here we're doing it by subtracting 3. Okay, all right, so we know that much information. Okay, we are tasked with two things here. We need to find A16, which is the 16th term of the sequence, and we also need to find a formula for AN. That's a formula for the nth term of the sequence. Okay, so for example, if we wanted to compute the 5,000th term in the sequence, we want to be able to pop in n equals 5,000 and get the 5,000th term spit out. Okay, it doesn't matter which order you do this in. If you want to find A16 first, go for it. If you want to find the formula first, that's great. My personal preference is to find the formula for AN first, and then you can use it to calculate A16. So that's where I'm going to start. Okay, we just learned that the formula for the nth term of an arithmetic sequence is given by the formula AN is equal to A1 plus n minus 1 times D. Okay, so we're going to use that. Okay, so I'm going to come over here and write that down. So AN is given by A1 plus n minus 1 times D. Okay, this is not the answer yet. This is the generic formula that works for any arithmetic sequence. We have to customize it for this particular sequence. Okay, so what do we plug in? Well, we have to plug in the A1 value, and we also need to pop in the D value. The AN is going to stay AN because we're coming up with a formula for the nth term. And then N is going to stay N. We need to be able to plug in an N value to get the nth term. Okay, so when you're using this formula, you're always plugging in A1 and D. And the great thing is we know both of those values. Okay, we know the D value is -3, and we also know the A1 value. Okay, A1 is the first term in the sequence. This is A1. Okay, so let's just plug these guys in. The nth term in the sequence is going to be A1, which is 23, plus n minus 1 will stay n minus 1, and make sure to use those parentheses. You're going to multiply this by D, which is -3. Okay, you should simplify. We can distribute here. You can distribute the -3 here and here. So that's going to tell us that AN is 23 minus 3n, then negative times negative is +3. So if we combine like terms here, we're going to get that the nth term in the sequence is given by 26 minus 3n. Okay, so this is the formula for the nth term in the sequence. Okay, so I'm going to write that in the box right here. AN is 26 minus 3 times n. All right, so this is the general formula. We can use it to get any term in the sequence, even the ones we already know. Okay, so now we're going to use it to calculate the 16th term. So I'm going to put this in a different color. If I want the 16th term, that tells me that n equals 16. So all I have to do is plug in n equals 16 into this generic formula. So A16, everywhere you see an n, replace it with 16. That's going to be 26 minus 3 times 16. Okay, this is going to be 26 minus 48, and then we can figure out that 26 minus 48 is negative 22. Okay, so this is the 16th term in the sequence. Okay, when you do something like this, you should just kind of eyeball it and make sure it's a sensible answer. Look at what our sequence is doing. We're starting at 23. We're going down by threes. We know the first 4 terms, and we're trying to think about what the 16th term looks like. Negative 22 makes sense. Okay, so that's all you have to do. We're done with this example. We figured out the formula for the nth term in the sequence, okay, and we used it to come up with the 16th term in the sequence, okay? All right, let's try example 4. This time, we're going to determine AN and A10 for the arithmetic sequence having A4 equals 18 and A5 equals 22. Okay, so we're doing a similar kind of thing. We're coming up with one specific term and then a generic formula for any term in the sequence. Okay, we have different information this time. We are given the 4th term and the 5th term of the sequence. Okay, and that's it. Again, I am going to start by coming up with the formula for the nth term, and then I will use it to compute the 10th term in the sequence. All right, so we're going to use the formula AN is equal to the first term plus n minus 1 times the common difference. Okay, again, we need A1 and we need D to specialize this formula to the specific sequence. Okay, so we're going to start by getting D. Why can we get D? Well, the given information, we have A4 and A5. Those are consecutive terms. So we can figure out the D value from these 2 terms, okay? All you have to do is look at this and say, okay, how do I go from one term to the next? Well, to go from A4 to A5, I need to add 4. So the D value is going to be positive 4. Okay, again, you could have looked at it and said, hey, if I take a specific term and I subtract the one that comes before it, meaning in this situation, I have to do A5 minus A4, that's going to give me 22 minus 18, which is positive 4. Okay, the D value is positive 4 here, not negative 4. Our terms are going up. You're going from 18 to 22. Your terms are getting bigger. Okay, all right, so we know the D value, but we need the value of A1. Okay, well, how can we get that? Well, only way I see is to do good old-fashioned addition and subtraction here. Okay, we know A4, we know A5, we know the common difference. Go backwards in the sequence to figure out A1. Okay, so we know A4 is 18. Okay, if we want A3, since we're going backwards, we're going to take 18 and subtract the common difference. Okay, so the 3rd term is 14, and then A2, you're going to take the 3rd term, 14, and subtract 4 to get 10. And again, I'm subtracting because I'm going backwards in the sequence. If I'm going down, if I'm looking at the first few terms in the sequence, those numbers should be smaller than 18. Okay. And then we can do one more subtraction to get A1. A1 is going to be A2, which is 10, minus 4, which is 6. Okay, so here is your A1 value. We need that. Okay, we need the D value, and we have that over here. Okay, and you know, if you just want to think about this for a second, it seems like everything is on the right track. If I wrote out the first few terms of the sequence, everything seems okay. The first term is 6, then 10, then 14. The 4th term is 18. The fifth term is 22, and so on. Okay, that seems right. Okay, everything is falling into place. It's making sense. Okay, all right. So now that we have D is 4, A1 is 6, we can plug into our generic formula right here. Okay, so I'm going to go ahead and do that. Okay, we're going to get that the nth term is given by the A1 value, which is 6, plus n minus 1 times the D value, which is positive 4. Okay, we should simplify. Okay, so let's distribute the 4. So we're going to get that the nth term is given by 6 plus 4n minus 4. Combine the like terms. The nth term is given by 4n plus 2. Okay, so this is how you can calculate any term in this sequence, even the ones we already know. Okay, all right, we are going to end by computing A10, the 10th term in the sequence. So if we want A10, that means that the n value is 10. N is always the value of the term you're looking at. I want the 10th term, so n is 10. So we're going to go to our generic formula here, and everywhere we see n, we're going to put a 10. So A10 is going to be 4 times 10 plus 2, that's 42. Okay, so that's the value of A10. Okay, if you wanted to simply count it out, you could have done that. Okay, if we had continued adding 4 in this direction, we ended up we left off on the 5th term. So the 6th term you would get by adding 4, then adding 4, adding 4, adding 4, adding 4. There's your 10th term. Okay, so sometimes these problems, you can do in more than one way. Okay, so we are done. Okay, you can see how useful it is to have a generic formula for the nth term of your sequence. Okay, that way you don't have to keep counting out the terms. It can help you get terms that appear later on in the sequence.